three forms of equations. We have absolute value, and now the last part is going to be introduction of sequences. And we're going to do sequences for the rest of this week before we review. So you need to be explain what a sequence is. You need to be able to do that. Generate terms in a sequence and find the nth term. We'll be looking at that today. Explain the recursive formula in the sequence and how it generates the next term. I wouldn't get too worried about that yet. The next one is the explicit formula. Again, that's not going to be today, but that will be this week that we're going to be working on those. And then I can convert numbers in a sequence into a function. So our functions are f of x, right? And when we think of functions, this is when we might be thinking of slope-intercept form. Or when we think of functions, we might be thinking of point-slope form of our equations. So when we look at these different sequences, later we're going to keep going back to that slope-intercept and point-slope. So as you are filling in your notes today, a blank is a ordered list of numbers that form a pattern, and that is a sequence. Each number is called a term or an element of your sequence. So this is on page 31. A sequence is simply a function whose domain is our counting numbers or natural. So before, when we had our functions and we talked about absolute value, we said, oh, it's all real numbers. This is not all real numbers. This is just the counting numbers. Because what I'm going to ask you about, these are some examples of a sequence. What's happening in the first one each time? What's our common difference?
Adding 2.
Common difference is that we are adding 2, right? If I'm looking at that next one, what does it look like we are doing? This one doesn't have a common difference. This one has a common ratio. Okay, so we're going to look at different. This one has a common ratio in that you're multiplying by 2, right? And then this one, does anyone know what that sequence is? This is a special one. It's a really, even has its own name. You know what it is? Nope, it's not Pythagorean. This is a special one. And this one is kind of weird. It's actually called the Fibonacci sequence. It's when you add these two together to get the next one. So 0 plus 1 gives you 1. Then you add the two previous ones. 1 plus 2 gives you 2. 2 plus 1 gives you 3. 3 plus 2 gives you 5. 5 plus 3 gives you 8. 8 plus 5. So it's a weird sequence. It's not like it's continually adding the same thing. It's always adding the previous term. So that one is a different type of sequence. But we're mostly, in today's lessons and in this unit, we are going to be working with the ones where you're doing common addition or subtraction. When we get into ratios, that'll be in a couple of units when we are doing exponential and different types of equations. So, as you look at that next page down, it says, look at this rectangular numbers. What is the pattern? So in the first one, what we want to take a look at, in the first one, we saw 2 dots, right? In the second one, we saw 6. In the third one, you can see 12, 4 by 3. In the fourth one, 20. And we want to look at what is that pattern as it continues. So, if we are looking at this, no, let's see, I'm going to go back and put that. So when we are taking a look at this, we want to be thinking this. Our first number in our pattern was 2, and that is 2 times 1. Our next pattern, or next number was 6, right? And that is, if we are thinking about it, 2 times 3. Then we had 12. 12 is 3 times 4, right? 3 times 4. The next one was 20. 4 times 5. What do you think the next one should be if we were going to keep going? 5 times 6, right? So we would think, oh, we got to keep the pattern going. 5 times 6 would give us 30, right? And now we're going to keep going. So if this one was 5 times 6, this one should be 6 times 7. 7 times 8, right? So we get 56. We got 8 times 9, 72. 9 times 10, right? And what if I said, okay, I don't want to go with a number, I want n. What do you notice is always happening? When it was 5, it was 5 times 6. When it was 4, it was 4 times 3. When it was 3, it was 3 times 2. So we could say that this is going to be n times what? How is 10 related to 9? If this is 9, how do I get 10? I do what to 9? Add 1. So this is going to be n, and this is going to be n plus 1. So it says, if we were going to complete this, which we just did for the 9 rectangular numbers, the question is this set and ordered pair going to be a function? So if we are thinking about this, does each input have one output? Yes, definitely a function, right? Each input has one output as we look at that. So is it a function? Yes, each input has an output. If we are looking at the next one, the domain, what did we say the kind of numbers that are going to be in our domain? They are only our counting numbers. Okay. So when we are looking at those, we have, yes, it's a function. We have our counting numbers, and it says how many dots are needed for the 10th figure. Well, we only got up to the 9th. But if we were going to do the 10th, we should have 110, right? Because we're taking 10 times 11. 10 times 11 is 110. So it says write an expression that models this pattern. So here is how we're going to write it now. This is different notation. We are not going to write it in equation form, f of x. We're not going to use y equals. We're going to write it this way. A sub n equals. What does that sub n mean? It just means the nth number in the sequence. Okay? We are going to write it as n times n plus 1. And then it says, well, before this was when we would have put y equals, and this would have been our x times x plus 1. Okay? But we're not writing it in function form. We're going to write it as a sequence. It says, well, what's the 100th number? Well, that means I'm looking for a, and instead of this being an n right here, we're going to put in 100. Which just means I need to replace the 100 with n in both places. So I'm simply taking 100 times 101. What is our 100th number in the sequence? Because I have this formula, I'm going to multiply that out, and it should come out to equal 10,100. Right? If you're taking this 101 and you're really just moving the decimal here over 2 places by multiplying by 100. So 10,101. Okay? So we use a special kind of notation. Similar to the idea of functions, we have a special notation. When we talk about the 10th triangular number that is 55, therefore we say the 10th term, so that you're going to have t sub 10, that just means the 10th term is 55. So when you look at how these are read, it's just a different type of way of saying it. So t to the 10 equals 55. We don't say t to the 10. We read it as t sub 10 equals 55. The little number is called the subscript or the index, and it just indicates the position in the term. So if I was asking you, this would be my first number in the term. T sub 1 is 1. T sub 2 means the second number in the term. My second term is 3. My third term, t sub 3, is 6. So if I wanted to make a list of these numbers, this is what the sequence looks like. It looks like 1, 3, 6, 10, right? This is the first number. T sub 1 equals 1. This is the second term in that sequence. So t sub 2 equals 3. So that's the notation, okay, that you are looking at. So as we look at this, it says the sequence are functions. Their domain is natural. We are representing them using function notation or sequence notation. So here it is a sequence notation. The term t sub n is equal to n times n plus 1. This is function notation. Do they look very similar? Yeah. They just put, instead of f of x, they put t sub n, and instead of x, they use n. Okay? So it's just getting used to that different way of writing it. So explicit formula is that next part down. An explicit formula is that describes any term in a sequence and its position in the sequence. Now, explicit is kind of nice because we can use it all the time. So it says this is an example, explicit formula in a sequence, because you can use it to calculate the nth term or explicitly by substituting in the value of n. It says, but I could use any other letter if I wanted to instead of n. So explicit, okay. So they're going to ask you, what's the 20th term as we are looking at this? So we're going to go up to this equation, and we're going to simply replace n with 20. That's all it means, is this n is now 20. So we have 20 times 20 plus 1, all divided by 2, which really, here's what a lot of you would probably write down. 20 times 21 divided by 2. Now, 2 goes into 20 how many times? 10. So 10 times 21 is going to give us 210, right? Could you simplify before you multiply this out? Sure, if you wanted to look at that. So 10 times 21, our answer is 210. We are looking at. Okay. Top of the next page. So as we are looking at this page, they are asking us to simply look at our equation. And as we are doing it, it says think of the sequence as perfect squares, where n is the number corresponds to the output. Complete the table. So if it's going to be perfect squares, so the first one would be 1, right? That's taking n and squaring it, which really means 1 squared, right? 1 squared is 1. Our next one should be what? 2 squared, which is 4. The next one, 9. Fill yours in, please. Is our formula. T to the n is equal to n squared, right? Which just means if I'm finding t to the 250, you definitely want your calculator for this one. We're going to take 250 and we are going to square it, correct? And if you think of 25 squared, this one comes out to be 62,500. Now, what if I asked you this question and I said 400 is what term? 400 is what term? What you do differently for this one is you would put in 400 for the t of n, okay? So going back to that original equation, t of n equals n squared, you would put this is 400. And you'd say, what squared gives me 400? And what number squared does give you 400? So the square root of 400 is 20. So my answer would be that this is the 20th term in the sequence. So if I ask you for what term it is, what you have to do is you have to replace the term here with 400, where if it says what's the value of t to the 250, that means this is the 250th term. Does that make sense, the difference in the question it's asking you? So when you're replacing that, just so when you think about those questions, okay? So, recursive formula. So that's what an explicit formula looks like. Recursive looks a little differently. Tomorrow we're going to work a lot with recursive, and then on Thursday again. So recursive, it says, is a piecewise defined equation that shows two things. It's always going to show the first term. So when you do yours, I'm always going to look for these two things. The first term, and then this is the rule. Okay? So the first term and the rule and how it's related to the previous. So we call the first one a sub 1. We're going to put in whatever is our first number in our sequence. Okay? And it will be when n equals 1. Now, that is when it's the first term. That's what that means right here. Here, notice they put a sub n, and you're going to have a rule here. And this will be when n is greater than 1. It says fill in the blank for the expression showing to do the previous term to get the next term. Then you're going to show the previous term by subtracting that subscript n minus 1, which just leaves us with n greater than. An example, 40, 20, 10, 5, 2.5. The first term, if we look at this, is 40. So when you write that down, we put a to the 1 is 40. This is when n equals 1. Notice it says this is optional. Usually you don't have to put this one. You do have to have this. This is required. So when I look for on the test or on a quiz, I'm going to look for the first term. I'm going to look for you to tell me a to the n. And what is the pattern here? Each time we are dividing by 2, right? So they wrote it as a to the n minus 1. Why n minus 1? Because if this is like the second term, right? If I think of this as the second term, what did I have to do? I had to take 40, and I divided it by 2 to get 20. That was my second term. This is, if I'm looking at this one, this is a sub 2 is 20. How did I get the next term? A sub 3. To get a sub 3, I took the previous term. That's all this means. This simply a to the n minus 1 just means previous. That's all it means. So what was prior to the third term? It was 20. So I take the previous term, that's the second term, and I divide it by 2, and my third term would be 10. Okay? So it's just a different notation. This n minus 1 only means previous. That's all it means. Okay? So we're going to look at the top of that next page at writing sum. So if we look at this, it says to repay a $200 loan, you make a you pay $20 each month. At the end of each month, you receive a statement telling you how much money you owe. Make a list of your outstanding debt after 6 months. Now, that means I want to know after my first payment, T sub 1 is equal to what? 200 or 180? 180. So this is probably the most common mistake on this one, is that people think you're starting at the loan was for 200 at the end of each month. So after month 1, we've already paid $20, right? So we're down to 180. So what is T sub 2 going to be? My next one should be 160. Okay? So could we list T sub 3, T sub 4? Please do that up to T sub 6. Okay? Please do that up to T when you're thinking about what that first term is. So now it says write a recursive formula. So a recursive formula, you're going to kind of put that bracket out in front. And since they called it T instead of A, we're going to put T sub 1. What was our first term? 180. Then we're going to put T sub n. And what was our rule? What are we doing each time to the previous one? So we're going to put T to the n minus 1, because all that means is previous. That's all this means. It's just a mathematical notation to say, instead of writing out the word previous, we put T sub times T to the n minus 1, or sub n sub 1. And we were subtracting 20. And you have to put this part. This is the required. For n, if it equals 1, we're up here. So we have to have when n is greater than 1. What is that n? That's talking about this being term 2, term 3, term 4. Each time we're subtracting 20. Okay? So we're looking at this one, and we're going to write a recursive formula. So tonight in your homework, you're going to be doing recursive. Recursive means, and when we start this out, you want to start with our first term. So try it. Put T sub 1 and your T sub n. Think about what is your rule to get the next term. What are you doing to get the next one? Okay? So, n minus 1, just telling me the previous one, and then what did you do? Plus 5. Now, you want want to make sure that this is kind of like this little subscript way down here. You don't want it to look like this, t n minus 1, right? Because that almost looks like t times. So you do want to make sure that when you're doing this one for that n, telling me that subscript, you do kind of want to make it small like that, okay? Questions as you are looking at that one, okay? So, your homework is on, if you would turn back to page